Hi and welcome. In this video, I will discuss a network authentication protocol known as Kerberos. And now you can see the diagram on the screen, and in this video I will discuss all the components of the Kerberos protocol and the flow of Kerberos protocol in single slide. So let's start. Now the Kerberos protocol was actually invented in 1980s by MIT, and Kerberos in Greek stands for three-headed dog, and the three heads of dogs are representing the different components of Kerberos protocol, that is the client and the server, and the central authentication system, that is key distribution center or KDC. Kerberos mostly depends upon symmetric cryptography. It means that the same keys are used on both ends of communication to encrypt and decrypt the data, the authentication data. So if you see the Wikipedia page, then you find that this protocol also uses asymmetric cryptography. Now the Active Directory domain controller of Microsoft has implemented this protocol since 2000, and Microsoft uses the protocol version 5 of Kerberos. So this protocol is multi-platform. It means that the Mac or the Linux or the Microsoft clients can use this protocol to authenticate and to get the services from an application server. Now this is the client machine, and this is one of the component or one of the head of the dog, which has three heads. So this is the first component of Kerberos protocol, and this client is also known as the principal. And second component is the application server. So the client wants to access a service hosted on this application server, and this service can be a print service or it can be a file. So the client and the server has no mechanism to authenticate each other. Therefore, they need a third party which is trusted by both the client and the server. So this third party is a key distribution center or KDC. So client and application server are part of a realm or domain of this KDC, and moreover, this Kerberos protocol operates over UDP port 88, which is the default port for Kerberos protocol. So client gets itself authenticated once by KDC, and then it has access to all the resources in the realm. Now the KDC has two other components, that is the authentication server and the key distribution, the ticket granting server, that is TGS. So a client requests certain tickets from both of these authentication server, that is the client first gets itself authenticated from the authentication server and gets its first ticket, and then it gets its second ticket from the ticket granting server based upon the first ticket, and based upon the second ticket, which is a service ticket, it then access the application server. In Kerberos, the processing burden to maintain all the tickets and the keys, that is the session keys, is on the client. Therefore, the application server or the KDC do not have to maintain all the keys and the service tickets for multiple or thousands of clients. So processing burden is shifted towards the individual client. Now if you just see the keys and the tickets which are maintained on the client and on the different servers, that is the authentication server, ticket granting server, and application server. So if you know the working of these keys and these service tickets, then you are good to go for as concerned with the understanding of this protocol. Now there are around 5 types of keys which are used in this entire protocol, and 2 types of service tickets. So there are certain keys which are maintained on the client. So these keys are maintained in the memory of the client. If a client gets powered off, then these keys and the service tickets are destroyed. And so what happens that the user enters its username and password into client machine, and then the client machine converts its password into password hash, and this password hash is stored as a key for future use by the client machine. Now the user do not have to worry about the internal working of the Kerberos protocol. The rest of the job is done by the client while it authenticates itself through the KDC, and then the client on behalf of user gets the services from the application server. So all the processing is done by the client. So user has to just enter its username and password. So what happens that first of all the client sends an authenticator which is encrypted with this password hash, and this password hash is also stored on the authentication server. So this password hash acts as a key, as a secret key or as a shared secret key between the client and the authentication server. And moreover, user also sends its user login, so that the authentication server can retrieve its password hash from the database by comparing the user login, and then it can use this password hash to decrypt the authenticator. Now this secret key helps to avoid the transfer of password in clear text over the network. So the password of the user is not transmitted on the network in clear text, rather it is transmitted, it is used only to encrypt the authenticator, and this encryption is also performed by the hash of the password, not the password itself. So this prevents from if anyone is sniffing on the network for the password. So nobody can able to make out what is the password, since it is not communicated on the network. So only the user ID is in clear text, and this authenticator is encrypted with the password hash. So once these information reaches the authentication server, then authentication server moreover, this authenticator contains the timestamp, and this timestamp contains the date and time of the client machine. So if this timestamp is checked by the authentication server once these information reaches the authentication server, and if this timestamp is more than 5 minutes, there is a difference of 5 minutes between the time of the authentication server and the client, then this authenticator is rejected by the authentication server. Now what happens that once these information reaches the authentication server, then authentication server compares the user login from the database and retrieves its password hash to use it as a key. So it then uses this key or the password hash of user to decrypt the authenticator. So after decrypting the authenticator, it checks the timestamp. So it should be within 5 minutes. Once these informations are validated by the authentication server, then authentication server send 2 pieces of information. First is the session key, which will be used for communication between the client and the ticket granting server. So this session key is also encrypted with the same hash of user password or the same shared secret, and therefore it is encrypted. And the second piece of information is the ticket granting ticket or the first ticket. So this ticket will be used in encrypted form by the client to get the second ticket, that is the service ticket, in order to get the service from the application server. So this first ticket or ticket granting ticket is encrypted with a shared secret key which is shared between the authentication server and ticket granting server. So this second secret key is only known to the authentication server and ticket granting server, but it is not known to the client. Therefore, the client cannot decrypt the information contained in the ticket granting ticket. So client can only replay these information. So the ticket granting ticket contains the login of the user and its IP address and its validity period, that is normally 8 hours. And moreover, it also contains the session key which will be used between client and the ticket granting server. So these 3 pieces of information or the 4 pieces of information are encrypted by using a shared secret key which is only known to the authentication server and ticket granting server. So once these information reaches the client, then client saves the information into its memory, and there is a specific portion of memory in the client known as Kerberos tray. So all the informations are stored in Kerberos tray regarding the tickets and the different keys, that is the session keys and the secret keys. And now there is also a utility known as Kerb tray. So you can use this utility to find the Kerberos keys stored on your client machine. Now what happened next is that the client again encrypt another authenticator by using its session key, which is still not known to the TGS, because this session key is encrypted inside TGT by using this shared secret key which is known to the authentication server and ticket granting server. Moreover, the client also replay the same ticket granting ticket or the first ticket in encrypted form, since client has no mechanism to decrypt this information. So this information can only be decrypted, or the ticket granting ticket can only be decrypted by the ticket granting server. So it cannot be decrypted by the client. So client can only replay it in encrypted form along with the service ID. So these 3 pieces of informations are played by the client to the ticket granting server. So ticket granting server has the shared secret key which is shared between authentication server and ticket granting servers. But so by using this shared secret key, that is the brown one, or the client, this ticket granting server decrypt the ticket granting ticket, and after decrypting the ticket granting ticket, the ticket granting server or TGS gets the session key. So after getting the session key, then the ticket granting server uses this session key to decrypt the authenticator sent by the client. Then it retrieves the information inside the authenticator, that is the user login, and it compares this user login with the login which is inside the TGT. So it basically compares the data inside the TGT and the data inside the authenticator. So if both logins are matched or both information are matched, it means that the client is the legitimate one, and moreover this ticket has been this TGT has been sent by the authentication server to the client, and client has just replayed it. So it performs a kind of authentication for the client. The client is the legitimate one. Now again, this ticket granting server makes these two pieces of information, that is, first of all, it prepares or sends another second session key. So this second session key is encrypted by using the first session key. So this second session key will be used between the client and the application server once the client will request the application server for a service. So this is in the encrypted form and it is encrypted by using the first session key. So and second piece of information is the service ticket, or we can call it a token as well. So this token is encrypted by using the shared secret key, which is shared between the ticket granting server and the application server. So this key is not known to the client, but it is only known to the ticket granting server and the application server. Therefore the client only stores so this token also contains the user login, IP address, validity period, and also the second session key. So these four pieces of information are encrypted by using a key which is only known to the ticket granting server and the application server. So client can only store this information inside its memory for 8 hours in encrypted form. So client can decrypt the second session key since it is encrypted by using the first session key, but the client machine cannot decrypt the ticket granting the service ticket or service token since it is encrypted with a key which is only known to the ticket granting server and application server. Now the client, after decrypting the second session key and storing into its memory, it then use the second session key to produce another authenticator or to encrypt another authenticator with login information and timestamp along with the encrypted service ticket. So client sends this authenticator by encrypting it with its second session key, and it also sends the service ticket or replay the service ticket in encrypted form since it has no mechanism to decrypt it. Now the application server then decrypt the service ticket since it knows the key with which it has been encrypted. So after decrypting the service ticket, it gets out the second session key, and if this service ticket has been decrypted, it means that this service ticket was sent by the TGS. Moreover, it also uses after retrieving the second session key out of the service ticket, it then use this second session key to decrypt the authenticator sent by the client. And after decrypting the authenticator and getting the user login out of this authenticator, then the application server compares the user login inside the authenticator and with the user login which was sent by the TGS inside the service ticket. So if both user logins are same, it means that the client is legitimate one. Then the application server checks the user group for any kind of rights which are imposed on the group and allows a user the access to a particular resource, for example a print request or a printer or a file. Now there are certain additional steps. So this additional step is that the client additionally uses the application server uses the second session key to encrypt the timestamp sent by the client, and it replay this timestamp to the client by encrypting it with the second session key. So this performs a kind of mutual authentication, so that if any man in the middle has requested any request from the application server, so this man in the middle won't be able to decrypt this timestamp. So whenever user has to access a particular server from the application server, then the user plays this encrypted service ticket each time to the application server. So therefore the processing burden is not on the application server to maintain the session keys and also to maintain the service ticket. So all these processing burdens are on the client machine inside its memory. Now there are certain issues with the KDC. So first issue which is very visible is that the KDC is a single point of failure. So if KDC goes down, then nobody can authenticate itself and gets access to resources on the network or in the domain. Moreover, there are different models of or different implementations of KDC, therefore it is not standardized so much. Moreover, the Authenticator timestamp is only valid for 5 minutes, and if the NTP is out of sync or the time of the client machine is out of sync with the KDC, then the authenticator gets rejected by the authentication server. So this was all from my side. Please stay connected to my channel for similar videos. Thank you.